Good morning, my dear students. Today, I am going to discuss the next unit, solutions. I am Dr.R.G, Professor of Chemistry, who is taking class for you. So, under the chapter solutions, let me give a short introduction to give a clear idea about what is solution. Solution means a solvent and a solute, a mixture of a solvent and a solute is called solution. Kindly follow. This is the most important. So, the solvent may be a solid, solvent may be a liquid, may be a gas. Same way, solute may be a solid, may be a liquid, may be a gas. Here, you have to raise a question. How to differentiate what is solvent, what is a solute? So, in a solution, whatever concentration is high, it is solvent. Whatever concentration is low, it is solute. Solvent normally expressed, that is subscribed by 1. Solute will be subscribed by 2 by convention in chemistry. So let me proceed. Here, what are the factors which affect solubility? So normally, I told you solute may be any one of 3 or solid may be any one of the 3. So what are the factors which affect the solubility? There are 3 important factors. Let me just mention aloud. Nature of solute and solvent will affect the solubility. That is, solute may be a solid, solute may be a liquid, solute may be a gas. The same way, solid may be a solid, solid may be a liquid, solid may be a gas. So this nature will affect the solubility. Number 2, temperature normally will affect the solubility. Whenever temperature increases, solubility increases. And pressure is another important factor in the case of gases. High pressure will increase the concentration of the gases, that is, solubility increases. Can you follow? Now, even though we have so many types of solutions, kindly follow. I told you solid solution, solid liquid solution, solid gas solution. The same way, then liquid solid solution, liquid solution, liquid gas solution. Like this, we have various combinations. But in this chapter, we are going to concentrate only one type of solution. That is, here we will give importance for a solution where solvent is always a liquid. Kindly follow. So we are assuming always solvent is a liquid. So, solute may be a solid, solute may be a liquid, solute may be a gas. So, solute may be a solid, solute may be a liquid, solute may be a gas. But solvent we are assuming always liquid we are considering. So, we are going to discuss in this chapter solution. Kindly follow. Now, so if you are considering this solution, keeping solvent as a liquid, so thus we can classify this solution into 3 types, namely, number 1, solutions of solid in liquid, solutions of liquid in liquid, solutions of gas and liquid. So there are three types we have. So let me discuss one by one. First one, solutions of solid in liquid. Here we have to first find out what type of solid will be soluble in a selected liquid solvent. Here normally water will be used as a solvent which is called universal solvent. In the laboratory, additional to water, normally organic solvent will be used like alcohol, ether, chloroform, methanol, like that here will be used. So first let me take now solution of polar solid in polar liquid. What is meant by polar? Polar can be measured by the dielectric constant. If dielectric constant is a property, physical property, if it is high, it is polar. For example, water. So I can write the structure of water in the form of V shape. Here will be positive, positive. Here is negative, negative. Kindly follow. So it's a dipole. So it is a polar. Water is a polar liquid. So same way, polar solid means, for example, sodium chloride is a polar solid. Positive and negative charge will be there. So the first type solution, I can call it as solution of solid in liquid. Now I am taking one type is polar solid in polar liquid. Let me give information, kindly follow. Generally, polar solids are freely soluble in water. Polar solids are freely soluble in water. Example, sodium chloride in water, glucose in water. Glucose is a carbohydrate. It is an organic compound. Sodium chloride is an inorganic compound. So they are freely soluble in water. So these two solutes, sodium chloride and glucose, are polar solids. Water is a polar solvent. Next one, solution of non-polar solid in polar liquid. So polar liquid, as usual, let me take water. Non-polar solid means normally hydrocarbon, naphthalene, anthracene. So in water, if you consider the solubility, they are insoluble in that one. So generally non-polar solid will be insoluble in water. Third type, solution of polar solid in non-polar liquid. So polar solid we have discussed already, sodium chloride is polar, glucose is polar, whereas non-polar liquid is hydrocarbon, generally N-hexane we can take is a polar, non-polar liquid. Hydrocarbons are non-polar liquid. So here solution. So what is happening here? When you dissolve sodium chloride in hexane and glucose in hexane, they are insoluble. And the fourth one, solutions of non-polar solid in non-polar liquid. Non-polar solid, naphthalene and anthracene. Non-polar liquid, hexane. So they are soluble. Please follow. They are soluble. So under the solutions of solid in liquid, we can further classify depending upon the nature. There are four types of solid solutions in liquid. Please follow. Okay. So let me go for the next one. Second solutions of liquid in liquid. So we have discussed solid in liquid. Now I am coming for liquid in liquid. So whenever we say liquid in liquid means we have to discuss about the vapor pressure of liquid, because Whenever we are placing a liquid in a closed container, some amount of liquid gets vaporized if it is volatile. Kindly follow. So, consider the solution of two volatile liquids like ether, chloroform, like that. You can keep now two. When taken in a closed vessel, both components will evaporate and eventually an equilibrium will be established between vapor pressure and liquid phase. Kindly follow. So we are taking a liquid solutions. Whatever concentration of liquid is high, it is solvent. Whatever concentration of liquid is low, it is the solute we have to assume. So when we are keeping two volatile solutes in a closed container, then let us assume let the total pressure of the two liquid solutions is equal to P1 and P2, where P1 is the vapor pressure of solvent 1, P2 is the vapor pressure of solvent 2. So P is the total vapor pressure. Or I can write in terms of P1 is equal to X1 into P total. That is the vapor pressure of individual component is equal to, it is mole fraction of the solvent into P. P total pressure. Kindly follow. 1 indicates solvent. P1 vapor pressure of solvent, X1 mole fraction of solvent. The same way, P2 it is for solute. Vapor pressure of solute equal to mole fraction of solute into total pressure. Please follow. Okay, let me continue. The French chemist Raoult gave a qualitative relationship between them. The relationship is known as Raoult's law. The relationship is known as Raoult's law, which states that for a solution of volatile liquids, the partial vapor pressure of each component in solution is directly proportional to its mole fraction of solvent present in the solution. Please follow. Vapor pressure of each component in solution is directly proportional to its mole fraction of solvent present in the solution. This is the most important of Raoult's law. Okay. So let me take a specific. Therefore, let me take P1, vapor pressure of solvent, is directly proportional to mole fraction of solvent. Or in order to equate, I am putting a constant P1 0. Therefore, P1 equal to P1 not X1, where P1 0 is a constant that is called vapor pressure of pure component. It's a constant. As usual, X1 is the mole fraction of solvent. Similarly, mole fraction of that is liquid solute is directly proportional to mole fraction of the solute. Or I can equate by putting a constant P2 equal to P2 0 into X2, where P2 0 is a constant, nothing but it is the partial fraction, that is the vapor pressure of the pure component of the solute. Kindly follow. Raoult. What is P total? So let me add this one. I know already P that is P total equal to P1 plus P2. So that what is P1? I know it is P0 X1 here, from here. And same way, what is P2? It is here. So I am adding now P total equal to P1 naught X1 plus P2 naught X2. So I am taking out common factor P1 naught within bracket 1 minus X2 plus P2 naught X2. Kindly follow. Now, let me come back. The conclusion about this solution. The total vapor pressure over the solution can be related to mole fraction of any one component. Total vapor pressure over the solution of liquid, can be related to mole fraction of any one component. Number two, the total vapor pressure over the solution varies linearly with mole fraction of component 2. Component 2, that is solute. 3. Depending upon the vapor pressure of pure components, the total vapor pressure over the solution increases or decreases with increase of mole fraction of the component. These are the conclusion we are arriving. Kindly follow here. Just look here. The left side we are having P1 dot, right side P2 dot. That is the corresponding that is the partial pressure of the corresponding component 1, P2 the partial component of the corresponding another liquid. So one indicates solvent, 2 indicates solute. Both are liquids. So now what will happen now? So when we are plotting this vapor pressure versus mole fraction, so we are getting a curve like this. So curve 1, it's a straight line, curve 2, another straight line crossing there, here at this point. And also when you connect P2 naught and P1, again we are getting a straight line, which is nothing but P total equal to P1 plus P2. It is the third line. So let me explain. Kindly have this in mind. I will explain. You can easily understand now. So a plot of P1 or P2, P1 solvent, P2 solid, both are liquids, versus mole fraction of X1 solvent, X2 solute for a solution gives a linear plot as shown above. These line 1 and 2 pass through the points respectively when X1 and X2 are equal to unity. Kindly follow. Starting from 0 to unity. Similarly, line 3, that is P total versus X2 is also linear. The minimum value of P total is P1 naught and the maximum value is P2 is P2 0. Assuming the component 1 is less volatile than component 2. That is, kindly follow, P2 naught is more volatile than P1 naught. Kindly follow this. This is the understand from this diagram. Kindly follow. So vapor pressure of P2 is higher. So that means highly volatile. Vapor pressure is low, comparatively less volatile. Kindly follow. Now, the third type, solutions of gas in liquid. Third one, gas in liquid. Many gases dissolved in water. Oxygen dissolved only to some extent, small extent. HCl gas is more soluble in water. Solubility of gases in liquids is greatly affected by pressure and temperature. So let me first discuss effect of pressure. So normally effect of pressure is applicable only for gases, we know. So gas is the solute and liquid is the solvent here. Henry, the first person, was the first person to give a quantitative relationship between pressure and solubility of solvent, which is known as Henry's law. Let us see what is Henry's law. Henry's law states that the solubility of gas in a liquid is directly proportional to the pressure of the gas. Solubility of a gas in a liquid is directly proportional to the pressure of the gas. The most commonly used form of Henry's law states that the partial pressure of the gas in vapor phase is proportional to mole fraction of the gas in the solution. Or, so when he plotted vapor pressure versus mole fraction of the solvent, here it is the HCl, mole fraction. So what will happen now? P is directly proportional to X. Kindly follow. So in order to equate, we are putting a constant. KH is a constant. So I am calling it as KH is nothing but Henry's law constant, where X is the mole fraction and P is the partial pressure of a gas in vapor pressure. Partial pressure of the gas in the vapor phase. Kindly follow. Now, different gases have different KH value at the same temperature. This suggests that KH is a function of nature of the gas. Very, very important. KH, that is Henry's constant, is a function of the nature of the gas. It is obvious from equation P equal to KHX. Kindly follow. Higher the value of KH at a given pressure, lower is the solubility of the gas. Please follow. This is the most important information. Higher the value of KH at a given pressure, lower is the solubility of the gas in the liquid. So for this, I will give a list where you can easily identify this information you can verify from the data given below. For example, KH values for both nitrogen and oxygen increase with increase in temperature, indicating that solubility of gases increase with degrees of temperature. Solubility of gases increases with the degrees of temperature. Let us see now here I have given gas, temperature and KH value in terms of bar. In terms of bar I am giving. Kindly follow. So I will take only two different temperature measured. Here there are a number of examples: helium, hydrogen, nitrogen, oxygen, carbon dioxide, methane is given. So I will take only these four I will take for comparison. Because the other cases only one temperature is measured, we cannot compare. So let me take N2, the temperature is 293. Now KH value 76.48. So same N2 high temperature, kindly follow, the KH value 88. So higher, kindly follow, higher the temperature, here in this case, the higher the KH value, solubility will be less. Kindly follow. Higher the KH value, solubility will be less. Kindly follow. So in this case, nitrogen, solubility is more in 293 for nitrogen, solubility is less in 303. When temperature increases, solubility decreases. That also we can explain in terms of KH also. Higher the KH value, solubility less, the same way. So temperature and KH we can correlate. Same way in the case of oxygen, 303 it is the value of KH 46.82. 2 in 93 the value is 34.86. So higher the temperature, solubility decreases. Higher the KH value, solubility decreases in the case of oxygen. Kindly follow. Now, effect of temperature. In the case of gaseous solute in liquid solvent, solubility of gases in liquids decreases with increase of temperature. Whenever a temperature increases, solubility decreases. When dissolved, the gas molecules are present in liquid phase, and this process of this solution can be considered similar to that condensation, and heat is evolved in this process. Kindly follow. So this is regarding for different types of solution. By using solvent is a liquid. Solvent is a liquid, and the solutes we have taken three different solutes: solid solute, liquid solute, and gaseous solute we have discussed. Now, under this, I have to give one important, most important is question, the competitive question will be asked here. So, ideal and non-ideal solution. Kindly follow. What is ideal? What is non-ideal solution? You must know. We have already come across in the case of gases, ideal gas PV equal to nRT. Non-ideal gas, the Van der Waals gas equation. The same way in this case, solution, ideal and non-ideal solution we will discuss. First one, liquid solutions can be classified into ideal. Please follow. I am taking liquid. Please follow. Even though I have taken solid liquid, the liquid and gas liquid. So I am taking liquid. Kindly follow. Liquid solution can be classified into ideal and non-ideal solution on the basis of Raoult's law. The solutions which obeys Raoult's law over entire range of concentration are known as ideal solutions. So the ideal solution have two other important property. What is the two other important property? The enthalpy, that is delta H value of mixing of pure components to form a solution, that is delta X mixing, equal to 0. Suppose if I mix two liquids, liquid 1, liquid 2, that is one will be solvent, other will be solute, and the total delta H of during this forming solution, delta H equal to 0. There is no positive value, there is no negative value, then it is called ideal solution. The same way, when you mix, what will happen now? The volume of mixing is also 0. Suppose I am mixing 10 ml, I am mixing another 10 ml. So 10 ml of liquid 1, 10 ml of liquid 2 I am mixing. So total will be only 20 ml. Only 20 ml. There is no difference. So we will say automatically delta V mix equal to 0. Kindly follow. It will not increase volume, it will not decrease volume. The volume of mixing is also 0. Kindly follow. It means that no heat is absorbed or evolved when the components are mixed. That is delta H equal to 0. Also, the volume of solution will be equal to sum of the volumes of two components. 10 plus 2, 10 plus 10 equal to 20. 20 plus 20 equal to 40. It will not increase greater than 40 or less than 40. Kindly follow. So, volume of the solution would be equal to sum of the volumes of two components. So, these both conditions are satisfying ideal solution. Ideal behavior of solution can be explained by considering two components, A and B. In pure, the intermolecular intermolecular attractive interaction will be of the types AA interaction, BB interaction will be there. Suppose A is one solvent, B is another solvent. So solvent A, solvent A interaction will be there. Solvent B, interaction will be there. Kindly follow. Whereas in boiling solutions, in the boiling solution, in addition to this interaction, when we are boiling, in addition to this interaction, there is also AB type of interaction will also be present. So when we are boiling the two solutions A and B, There is AA interaction, there is BB interaction, also there is AB interaction. And we have to compare the strength of these three. Based on that, we will classify what is ideal, what is real. Kindly follow now. If the intermolecular attractive forces between AA and BB are nearly equal to those of between AB, please follow. Attraction between AA and BB are nearly equal to those of between AB. This leads to the formation of ideal solution. Formation of ideal solution. A perfectly ideal solution is very, very rare. But to some solutions are nearly ideal in behavior. So example for ideal solutions, N-hexane, N-heptane. Kindly follow, it's an hydrocarbon. N-hexane 6 carbon atom, N-heptane 7 carbon atom, linear chain. So they are mixed, they will behave like this. What will happen? Delta X will be 0, delta V will be 0. The V will be equal. Kindly follow. Number 2, bromoethane and chloroethane, another example. Benzene and toluene. So these three examples are ideal solution. Kindly follow. That means the AA interaction and BB interaction is almost nearly equal to that of AB interaction. So for examples is NHN, N-heptane, bromoethane, chloroethane, benzene and toluene. Now, what is non-ideal solution? When solution does not obey Raoult's law over entire range of concentration, then it is called non-ideal solution. The vapor pressure of such solution is either higher or lower than that of predicted by Raoult's law for ideal solution. It will be either higher than the vapor pressure predicted by Raoult's law or lower than the vapor pressure predicted by Raoult's law. That we'll call as non-ideal solution. Suppose if it is higher the solution exhibit positive deviation. If it is lower, it exhibits negative deviation. So higher positive HP. If it is lower negative LN. Please remember. Higher means the vapor pressure. We are considering the vapor pressure. Kindly follow. So now see here the examples. So I am showing here vapor pressure is plotted versus mole fraction. Here is P1 and this is P2. P1 means one solvent, P2 another solvent. In this case, P2 solvent is considered as a solute. So dotted line indicates the Raoult's law obeying the ideal solutions, whereas solid line indicates the deviation non-ideal solution. So in this case, kindly see here, it is greater. Kindly follow. In this case, this is greater than ideal solution. Here again, greater than ideal solution. Here again, greater than ideal solution. In all the three cases, the vapor pressure is greater than the ideal solution, according to Raoult's law predictions. Coming for this side, this is lower. This is the predicted by Raoult's law. Dotted line indicates 1. These are straight like they are. Now, when you mix 1 and 2, kindly follow what is happening now in this case. What is happening now, it is lower means lower than the predicted, the ideal, lower than the ideal, lower than the ideal solution. Kindly follow. So, if it is only dotted line, straight line, it is ideal. Either greater than ideal or lower than ideal, it is non-ideal. Please follow. Let me go. Non-ideal solution. The cause of these deviation lie in the nature of interaction at the molecular level. In the case of positive deviation, high vapor pressure, kindly follow. Positive deviation, AB interactions are weaker. So we have AA, we have BB, and also we have AB. So always during boiling, we have three interactions. So when we are saying non-ideal solution, if all the interaction almost equal, ideal. Whereas in the case of positive deviation, A, B interactions are weaker. Kindly follow. A, B interactions are weaker than those of AA or BB. In that case, it is a non-ideal solution. Specific example, ethanol and acetone mixer. Carbon disulfide and acetone, these two shows positive deviation, and here AA interaction and BB interaction is greater than AB interaction. Similarly, in the case of negative deviations, kindly follow, the intermolecular attractive forces between AA and between BB are weaker than, kindly follow, weaker than AB. Kindly follow. So AB is stronger than AA and BB and leads to decreasing in vapor pressure, resulting in negative deviation. So weaker negative deviation, it is the positive or it is stronger deviation. Kindly follow. This is the most interesting information regarding. So non-ideal solution here, the example, one is phenol and aniline, another is chloroform and acetone. Specific example of showing negative deviation. Kindly follow. Next, one more term I have to specify before completion of this, complete this unit. Azeotropes. What is azeotropes? Some liquids form azeotropes which are being mixer having same composition in liquid and vapor pressure and boil at constant temperature. In such cases, it is not possible to separate the component by fractional distillation. There are two types of isotopes, namely minimum boiling isotopes and maximum boiling isotopes. What is it? A simple example. Kindly follow. We can take now water and alcohol. A simple example we are going to see. Water 73, that is 8.3, this is 100 degrees centigrade. Kindly follow. So, 78.6 something, okay, 78.6 or something. So, what will happen now? Water and alcohol, a particular composition combines and form as a single solvent and a particular composition and boils at a lower boiling point that of pure water and alcohol. That is, water is 100, alcohol is 78.6. I have returned to the reverse case. So water is 100 boiling point, alcohol is 78.6. So the boiling point of this resulting mixture, it is having a constant composition is less than 78.6. So that let me come for specific example, kindly follow. Minimum boiling azeotropes. I told you ethanol 95%, 78.3, and water is 5% under degree pure. So what is happening now? The pure alcohol 78.3 is the boiling point. Pure water 100 degree pure water. So when you mix these two and if you distill by fractional distillation, so the liquid that is coming out will be a boiling point of 78.13. It is coming out. What is the composition that is coming out now? 95% of alcohol and 5% of water combining to form a liquid, and this liquid coming out at a boiling point of 78.13. So this isotope, we'll call it as below boiling, minimum boiling isotopes. It is lower than 78.3, it is lower than 100, it is 78.13. Kindly follow. So solution which show the past deviations from Raoult's law form minimum boiling isotopes at a specific composition. Next one. Maximum boiling isotopes. The solution which show negative deviations from Raoult's law form maximum boiling isotopes at a specific composition. Example, a mixture of nitric acid and water. Take nitric acid and take water. The water boiling point 83. The nitric acid is 83. Water is 100. That is the original boiling point. Kindly follow. The water is, it is given wrongly. It is 100 degree. Kindly follow. 83. This is 100. So after forming the mixture, a particular composition. What composition? 68% of nitric acid, 32% of the water, they combine and form a single solvent, and the boiling point is 120.5, it is coming out. Kindly follow. This is the maximum. Originally, nitric acid is 83, water is 100. So this 120.5 is greater than 83 and greater than 100. So what will happen here? So what will come now? Nitric acid will come out first, then come out pure water. That only, the final only, the mixture will come. But in the other case, only the mixture will come first, then only alcohol, then only water. Kindly follow. So this is called maximum boiling isotopes. I hope you have a very clear idea. Let me stop with this. My dear students, so I have discussed under these solutions different types of solutions. Under this, ideal and non-ideal solutions, and isotopes and the isotope with the minimum boiling point, isotope with the maximum boiling point I have discussed. Question may be there, you should be very careful. My dear students who are coming for the first time to view my NEET Chemistry by Dr.R.G channel in YouTube, please click like and share with your friends and press subscribe button to motivate me. And for other students that is waiting for NEET entrance examination for Government of India, that is +2 studying and +2 passed and waiting for second time to write a NEET entrance, for you I have very, very good important information. That is, we are running a coaching center with name Vetri Coaching Center in Pondicherry for the last 21 years. And we have a site website vetri.s. And if you go our vetri.s site, in the home page, you can view our achievements for 20 years. 1 or 2 achievements I will inform as my duty. Every year, 15 to 20 students are joining JIPMER Medical College. 150 to 200 students are joining in other medical colleges. Hundreds of students are joining in other engineering colleges. A few joining few of the students are joining in IIT. The second most important record is in 2003, R. Srinivasa Raghavan from Patrick School got All India first rank in JIPMER. At that time, there was no NEET entrance examination, which is a separate examination for all. Now, so for the students who are waiting for the NEET entrance examination, I want to give 3 important features that we have wetty daughters. That you must understand that. What is that? The wetty daughters has 200 video lesson, 200 unit test. 200 video lesson recorded by the professors having doctorate degree with 20 to 30 years of experience teaching BSc, MSc, MPhil, PhD, and also the IIT and medical students. They have experience. So in the video, when you are viewing now, that is the entire notes will be there in the video. If you want, just touch the video, it will stop. You can note the definition, equation, diagram, anything you can note. Then again touch, it will move. So any number of times you can repeat that video and you can take. The second is 200 unit test. So for example, in this case, solution. So in the solution, you have two tests. Test 1, test 2. Each one having 45 questions. So all the questions of solution are taken from 20 years of IIT question paper, 20 years of AIMS, AFMC, AIPMT, MSET Andhra, Delhi, Karnataka, etc. That is from 1980 to 2015 we have taken questions. Then you can raise a question for me. What is the advantage, importance of the question papers framed from IIT, AIMS, etc.? We have observed for the last six years, in it 75 to 80 questions of our questions or same questions are repeated. Same questions are repeated in NEET entrance examination. That means wetty daughters will give you 300 plus. And if you are a good student, hard working, sincere, you will get 300 plus. So automatically you will get 600 to 700. Automatically you will become your all India rank. You will join wherever you want. You will become a doctor. This is one important information I want to convey. The second important information I want to convey is our test. In the test, kindly follow, this facility is not available in other online entrance coaching, the online coaching. So there is a menu called attempt. Each unit, press attempt, immediately it will ask you, this unit contains 45 questions. Each question carries the 4 marks. The correct answer 4 marks, wrong answer -1. Are you ready? If you say OK, click. Then clock will run in the reverse order, 45, then 44.59 like that. Then you can see the question number 1. So you can see option A, option B, C, D, and there are 3 menu again you can see. The center menu is complete, and the right side menu is next. Left side menu is reverse. So suppose when the question is open, and below again there is again the window 1 to 45 questions in yellow color will be there. In yellow color it will be there. Suppose if you answer A is the correct answer, if you click, automatically you observe the question number 1 change the color from yellow to green. That means you have attended the 1. So number 2 will be in blue color, all other color will be in yellow color. My dear students, so what is the idea here is, you will know that when you are ticking the questions, you know you have what question you have answered, what question you have not answered, you can able to see in wetty daughters. This facility is not available in other online coaching. The second most important thing is, kindly follow, next you have to click for going upward, reverse you going for downwards, or from the 1 to 45 questions, where you can see any question you want, you click that yellow, that question will open. The most among all, what is another important thing is, kindly follow. I want to give one important guideline. You have to follow 3 steps those who are writing for NEET India examination. So you have to follow botany first, zoology, chemistry and physics. This is the method you have to follow. So there are 3 steps you have to follow. Step 1, answer all the known 100% known question from starting from 1 to 200 questions. Number 2, so again starting from 1, going any other question not answered, only theory question, think twice or thrice. If you assume it is 80% wrong, correct, put tick mark, otherwise don't answer, don't click. And third step, go to chemistry and physics, attend the problems. So by applying suitable formula and multiply, divide everything, utilizing proper units. And if you are getting the answer solution, it is identical with the your answer given. So in the option A, B, C, D, then put a tick mark. Otherwise, don't. So if all the 3 steps are over, kindly verify from the right hand corner any question is left or not. It is not necessary you have to write all the questions. You have to write only known, 100% known question you have to. So this is the method, it is there. Kindly follow. After that, after finishing everything, you please click. That is our complete. The menu, you click. Immediately, a window will open. In the window, you will get the marks. Suppose 160 by 180 you are getting. Because we are giving 45 into 4, 180. So 20 mark you are losing on, that is 5 questions you have done mistakes. How to identify? This is easy. There is a menu called a review menu is available next to the mark. You press the review, immediately a window will open. In the window, question 1 will be there. A, B, C, D option will be there. Below there is video solution will be there. And here correct answer. Correct answer. So, kindly follow, my dear students. If A you have written as the correct answer, it will be in blue color. Correct answer will be in yellow color. So you can easily identify your answer and correct answer. And if you are having doubt, you can view the video solution. It will run 10 to 15 minutes. It will run. But the professor will take class, reading the question, reading the options, then explanation, definition, formula, diagram, if any tabular column, everything he will discuss like ordinary class. So that even a dull student, a very poor student can easily catch the point. But this is not available in other online coaching. If you go for other online coaching, they will give only one line statement they are giving in the written form. That is not sufficient to understand, my dear students. Please understand. So our online coaching is far, far better than any other coaching in India. And the most important information I want to give, ours is low cost. Only 10,000 rupees per year you have to pay. So even when you join +1, better you join with your daughters. 10,000 rupees sufficient for you, you can. So how to pay these 10,000 rupees? Pay 10,000 rupees in the name of Sandhi, Director, Vetri Coaching Center. Indian Bank number, account number 712719471. IFSC code IDIB 000P134. And if any doubts or anything, you contact me, my cell number and WhatsApp number 9894176 So, thank you, my dear students. Bye-bye. See you again in the next chapter.